Hey y'all, I miss you. Okay, so we are into exponential functions, which is extremely useful for life, particularly when it comes to finances. Exponential functions affect everything from mortgages to savings accounts to credit cards to just about anything you can think of, including the coronavirus. So we're going to look at this particular set that we're going to start with a very easy function. This right here is put out by Discovery Education, which is affiliated with Discovery Magazine, which has a lot to do with, they've published a lot of NASA articles. So they've done a really good job of bringing this down to a pretty manageable level, because if I started out introducing this topic with what happens with credit cards, you would be kind of freaked out because they're pretty complicated. So they start out with one of the simplest to explain exponential functions, which is d of x equals 2 to the x. So when we're looking at that particular function, we are thinking about something that doubles every time. So every hour, maybe. In this particular case, it's every round. It says that right there. So we've got divers competing in a diving tournament, which if you've ever been to a diving meet, they are very boring. So I'm very confused about how they have so many participants, because usually diving meets are pretty low attendance. I used to be a diver. Okay, so there are 6 rounds. How many divers can participate at D of 6? Well, what you need to remember, which you probably do not, is that D of x and D of 6 are the same thing. Part of the reason you don't remember is because you haven't been back at school, and part of the reason you don't remember is this little stinker right here looks so weird. You're not used to seeing something that looks like that. So instead of writing 2 to the x, we're going to write 2 to the 6th. And when we write 2 to the 6th, it just looks like that. And that's the same as 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, times 2, which is 64. And I'm about to write that out. Okay, so I'm going to go through the process that I just went through again, because you should be able to manage these 2's. I counted these 2's on my fingers. 2 times 2 is 4, times 2 is 8. Oops, that's not writing. Times 2 is 16. Times 2 is 32. Times 2 is 64. Again, I count this all on my fingers. This is the one time that I don't care if you use your fingers in general, but I personally don't. This is one time when your fingers are super useful. So 2 is just 2. That's 1. Then times 2 is 4. 2 fingers should be out. Times 2 is 8. Times 2 is 16. At this point, 4 fingers should be out. Times 2 is 32. Times 2 is 64. And you should have 6 fingers held out. Now we need to figure out how many rounds are needed to get to 256. Well, we already know that 2 to the 6th is 64. What if we multiply that by 2 more? Well, that would be 2 to the 7th, and that would be 128. Remember, we're trying to get to 256. Well, let's try one more. 2 to the 8th, that would give us 256. So the x value there is 8. I'm getting better at this, y'all. Okay, sorry, this software is really weird to use. Okay, so A, even when you're talking about savings accounts and credit cards, that will always be the initial amount. And B will always be what it's growing by or shrinking by. and that is called the multiplier. And in most cases, it's what it's growing by. But if you're talking about something like the Richter scale, hurricanes, archaeology, figuring out the age of a dinosaur bone, those are all going to be shrinking quantities. Those don't affect you so much like financially. They do occur in your everyday life, but they're kind of under the surface. So this multiple is what the initial amount. Make sure you're writing all this stuff down. I usually pause when I write like this because it's really hard for me to talk and write at the same time. Okay. Right now, let's talk about the stock market. Not that most of us have to worry about that, but when you're thinking about the stock market, particularly with respect to retirement funds, right now, what everything is growing by is a lot smaller than it was, say, even 2 months ago. So, moving along. We get to the next page. Let me make sure I'm on the next page. Yes, I am. Okay, so we're going to work through this, and I am going to pause for a minute because I am taking too long. Give me a second. So this says that there were 3 people in the audience when the tournament began. And it says that, whoops, that didn't work out very well, did it? It says that in 30 minutes, each person, oh, I wrote down the wrong number, dude. What? Okay, so there are 3 people in the beginning, so that should be f of 1. So I wrote down 6, so I'm going to fix that real quick. But at the end of 2 hours, there's going to be 6. Then, I'm sorry, not at the end of 2 hours, at the end of 2 half hours. I'm having a lot of trouble, aren't I? At the end, wait just a minute. This is, my brain is not here. Okay, let me see if I can clarify. This is the beginning. This is 30 minutes in. This is 60 minutes in. And we need to get to an hour and a half, and an hour and a half is 90 minutes. And at an hour and a half, we're going to have 24 people. Now, how did I get that? I did it trying not to think about the math and instead think about what the problem says. We start with 3 people. Each person invites 1 person, so that's going to be 6. From those 6 people, each person is going to invite 1 person, so that's going to be 12. From there, each of those 12 people invites 1 person, and that's going to be 24. Okay, so the function rule here would be f of x equals 3. That's our initial value. And each time that number is doubling. So in order for it to increase by 2, we've got 2 to the x. How many people will be in the audience? 24. And I'm going to draw the tree diagram below. And I did make a mistake on my Zoom meeting yesterday, and I apologize to those people. I'm going to draw a tree diagram before and try to make it clear what's going on. Okay, so it's really hard to fit all this in, but if you count all of the people up in there, you should see 24 people, I hope. Let me double check. Okay, I got totally turned around. I expected that to look more like a regular tournament bracket. It doesn't really work out like a tournament bracket. So if you look carefully, so in that first row, each person, or in that first column, each person invited 1 person. And then in that second column, both of those people had to each invite another person. So 2 people invited 2 people. Then we have 4 people. Oh, that didn't work out very well, did it? 4 people inviting 4 people. That's how that all works out in that drawing. Okie dokie. I don't like the drawing very much, though. I think it's more confusing than helpful. Okay. In a different tournament, the audience also started with 3 people, but 10 additional people joined the audience every half hour. So what you're seeing here, it says additional. So we're talking about 3 plus 10, and X is every half hour. So after only a half an hour, there are 33 people. Add 10 more, they're going to be 63. Add 10 more. Oh, that's not 10 more. What? Me cray cray. I'm already at the end. 3 plus 10x. 13. Hello, I know how to add. 23 and then 33. See, I was already at the end. Okay, so at the very end, after 1.5 hours, you're going to have 33 people. Would you predict that g of x and f of x are consistent or inconsistent? Both are going to have the same pattern throughout, so they should both be consistent. I have a stupid faculty meeting in 10 minutes. Y'all, all I really care about is you. I don't care about dumb meetings. Okay, so they're both going to be consistent. They're both growing. They're growing at the same rate. It just looks different, right? One just happens to grow by 10 every time, and one happens to double every time. Okay, slide number 4. We're going to go ahead and graph them. I'm going to graph them, and you're going to check, while I graph them, you're going to check your work. Okay, looking at this, you should see that the curve is growing way faster and very quickly. It's going to overtake the blue curve, the straight line, and you're going to have that exponential function, which was f of x, is going to grow way faster. Oh, my handwriting, y'all. F of x grows faster. So sooner or later, you're going to have more people in the auditorium for that first scenario. Okay. Last bit. Let me double check. Okay, this last page you should be able to do on your own. I'm sorry this video was so long. I hope y'all have a fabulous day. I miss you terribly. Please, please take care of yourselves. I miss you, and I can't wait to see you in the fall. Let's hope we get to see each other in the fall. Bye.